Hi, welcome to Toy Teardown. In this episode we're building this LED lightsaber igniter, and it costs a couple of bucks and anybody can make it. Let's see how it's made. About 10 years ago I made this Darth Maul type lightsaber. Just used a PIC micro and a driver chip. It was a pretty simple circuit. The only problem with this circuit really for anybody else to make is you need a bit of computer knowledge and programming knowledge to be able to get the chip going or get the circuit going. So I thought, well, there must be an easier way to do this, so just about anybody with a soldering iron would be able to put this circuit together. So in this project I've designed the circuit, so basically all you have to do is go and get the parts, put it together and it'll work. They're just cheap chips which have been around for years. And if you follow this layout and put it all together nicely, it'll just work. So let's just have a look at what the kit's made of and get started. So here's our completed board. I'm not going to assemble an entire board. For all the instructions to put this board together, if you go to the instructable in the link, it gives you all the components and everything to get this up and running. I'm just doing this video because there's a couple of gotchas that you should probably know about. It might help just to make your building a little bit smoother. So I'll hook a battery up and just to show you how it works. So it's comprised of these three chips really. We've got an output chip here which is the ULN29003, I think it is. ULN2003, so this is the guy who does all the heavy lifting. It'll turn on, like I say, 500 milliamps per pin, which is huge. So this LM3994 is like a VU chip. It measures any input voltage out and the amount of voltage going into it. It turns on the amount of up to 10 LEDs. So what I've got here is this circuit which is based on an op-amp, which is like a bootstrap circuit. So when the power gets applied, the voltage goes up, levels off and stays on until you flick it off, and then it goes down again. So basically you've got time in volts. So when you power it on, the voltage ramps up, stays the same, and then when you power it off, the voltage slowly drops off again. So this chip is sensing that voltage and it's turning the LEDs on and off. So I'm just using it's a rail-to-rail op-amp. Some op-amps don't work from 0 volts to the maximum voltage, or 0 to 5 volts. They sort of work in between. For this circuit to work, obviously it needs to go all the way down to 0 and back up to its maximum voltage if it can. For my circuit I've used an LM358, but anything rail-to-rail will probably work. I've got a resistor bank here. A row of resistors. You can get those in packs, not made up like this, if you're living in the right part of the world. And we've got a little trim pot here, so I can adjust the amount of time it takes for these LEDs to turn on and off. So we just flicker on, and you can see it turns on. That's the voltage slowly raising through this. It's like an RC circuit, a resistor and capacitor circuit, so it's slow to pump up, and then we kill it off, it's slow to go down again. So if we adjust this timer, it takes a little while to turn on then, and slow for it to go up. And slow for it to go down as well. So when you build your circuit, you might want to make a bigger pot there, one with a larger resistance to get a even slower response. I think this is probably about right. the value I've got in there. So the first thing you need is a strip board or a vary board, or there's lots of different names for it, but basically it's just a circuit board which has got lines of copper, not the holes, because you get ones that are just holes, but lines that go all the way across the board, and with a knife you have to cut through tracks which we don't want to conduct anymore. So on the instructable, it'll show you exactly which lines to cut through, and then put your components on. So it's optional. You can just solder these chips straight onto the board, but if you're anything like me, you'd make lots and lots of mistakes, and it's really hard to get these chips out once they're soldered in. So for me, I just use sockets. They're fractions of cents, and it's worth popping those in just to save you the frustration of having to ruin the chip trying to get it out or going through chips. Down here you can, I've just used this plug. You could probably just solder your wires straight in if you're confident about how far you need the leads to be. This one just unplugs, so I can plug anything into that. On here I've got say it's 7 LEDs. This chip can drive 10. This driver can only drive 7 outputs, and each stage of your, if you're going to use it for a lightsaber, I mean the ones you get from, the ones you can buy from the store with LEDs that light up sequentially, they've only got 4 banks. So this is 7, so it's kind of overdoing it a bit, but I've got a blade I've made for mine that only uses maybe 4, maybe 5, and you still get the same effect as you would have seen in the video. For this to function correctly, I need this row of row of resistors to pull the voltage up so it stays high, and all it is just a row of resistors which are all the same value, with their leads all joined together, and they're all going down to the positive rail, so that just keeps it high. So they're all the same value, just tie them all together, have a look at the instructable how I've done it. Otherwise you'll have issues with this not turning on correctly. If you've never built anything with a circuit board before, just some tips. Once you've got all your cutting done on the bottom, you're ready to solder stuff in, start with the lower stuff first, like these links, and then sort of build your way up to the higher stuff, because if you start with the higher stuff, like these chips, all the plug even, all these things start falling out and looks hideous. So start off with the wire links first, then go for the resistors, the diodes, and just sort of start from the bottom and work your way up. And again, I thoroughly recommend just getting these little sockets, so if you do make a mess of it, you can throw the strip board away and start again. The strip board, it's easy to cut, so if you get your Stanley knife or a box cutter or whatever, and just score across the edge several times and then sort of twist it, it makes a nice clean break like that. I've done it to the edge, but too close to the edge over here of the board itself, so I've got this dead area which I could probably file off if I wanted to, but if you're making yours, you might want to think about cutting it in the middle of the board so you've only got a very small gap on this side, so it'll be smaller in size. I've tried to make this as narrow as possible, and this is the best I can really do with the sort of strip board that I've got. So I've based the circuit off a 9-volt battery. If you're clever, you can probably have a play around with this resistor and capacitor to run a smaller battery or a lower voltage perhaps. 9 volts seems to last for quite a while. This circuit, unfortunately, just the way I've wired it's always sort of draining a little bit of current even when it's switched off. So you may want to put another switch in here if you find it tricky getting the whole thing together. You need a main power switch and then the switch for the actual blade itself. As far as making a blade, obviously a blade's going to be a whole lot of LEDs in a row joined together. I'm not going to go over making that in this show because there's millions of tutorials on making blades. I have made one for my previous project, which I'll add in the show notes. And it explains how to put a blade together if you wanted to. I mean, there's lots of different ways to do it. Also, I use that blade with this board and it seems to work fine, even though it was running a slightly different configuration. So all these chips have been around for 20 or 30 years, some of them, so they should be easy enough to get off even eBay or Amazon. Well, not Amazon, probably at eBay. You better get all the components for this for just a few dollars. So go ahead and see what you can do with it. Okay, so here's a blade I made for this project 10 years ago. It's pretty sturdy, it's stainless steel and a couple of thumb screws here that used to go into a vacuum cleaner pipe, and we had another one on the other end, but unfortunately the other one got smashed. So because I've got a bajillion lights in here, you're not really going to see the effect of this powering up and powering down. So what I might do is just kill the lights. Okay, so let's put the lights off, find my switch. So you can see that sort of ramp down and ramp up effect. That's it for this show. As always, a thumbs up or a subscribe. Catch you next time.